out beyond the familiar glow of our sun, past the drifting silence of the outer planets, beyond even the frozen boundary of the Kuiper Belt, space does something unsettling. It stops behaving like the calm, predictable void we imagine, and instead starts whispering, not with sound, not with anything a human ear could ever perceive, but with pulses, bursts of energy that appear, vanish, and then, impossibly, appear again. For decades, astronomers believed the universe, while chaotic, followed rules that could be traced, mapped, understood. But every so often, something breaks that expectation. Something repeats when it shouldn't. Something returns when it should be gone forever. It begins, as many discoveries do, quietly. A telescope aimed at nothing in particular, collecting background noise, the cosmic equivalent of static. Radio telescopes are designed to listen to the universe, to translate invisible waves into patterns we can analyze. Most of what they pick up is exactly what you'd expect. Distant stars, collapsing gas clouds, the faint afterglow of ancient cosmic events. But hidden inside that data, buried under layers of randomness, are signals that don't quite belong. Signals that are too structured, too sharp, too deliberate in their timing. In 2007, researchers stumbled across something that didn't fit. A single, intense burst of radio energy that lasted only milliseconds. It was over almost instantly, like a cosmic flashbulb going off in the distance. There was no warning, no follow-up, no clear origin. It was cataloged, noted, and then left behind as an anomaly. But anomalies have a way of multiplying. Soon, more bursts were discovered, each one brief, powerful, and seemingly isolated. They were given a name that sounded almost clinical, almost harmless: fast radio bursts, or FRBs. At first, the assumption was simple. These were one-time events, catastrophic cosmic explosions. A star collapsing into a black hole, perhaps, or neutron stars colliding in violent final moments. The kind of event that happens once and never repeats. That explanation made sense. It fit neatly into what we already understood about the universe. But then, something happened that complicated everything. One of the signals came back from the same location. A second burst, then another. The idea that an FRB could repeat was not just surprising, it was disruptive. Because whatever was causing it wasn't being destroyed in the process, it was surviving. And more than that, it was active. Astronomers began focusing their instruments on these repeating sources, tracking them with increasing precision. What they found only deepened the mystery. The signals weren't just repeating, they were structured. Some came in clusters, others followed patterns that hinted at cycles, almost like a heartbeat, though not a steady one. It was as if something out there was turning on and off again and again across unimaginable distances. And here's where it starts to feel strange. These bursts are not weak. By the time they reach Earth, after traveling billions of light years, they still carry enormous energy, which means at the source, wherever that is, the power involved is almost incomprehensible. In a fraction of a second, a single burst can release as much energy as the sun does in days, sometimes even longer. And yet, whatever is producing this energy isn't being destroyed. That narrows the possibilities dramatically. Scientists began looking at the most extreme objects in the universe, because only extreme objects could survive something like this. Neutron stars quickly became the leading candidates. These are the collapsed cores of massive stars, incredibly dense, incredibly magnetic, spinning at high speeds. Some neutron stars, known as magnetars, have magnetic fields so intense they can distort atoms themselves. If anything could produce repeated high-energy bursts without tearing itself apart, it would be something like that. And yet, even that explanation feels incomplete. Because while magnetars can produce bursts, the patterns we're seeing don't always line up neatly. Some repeating signals behave in ways that suggest more than just chaotic emission. They suggest modulation, variation, a kind of internal logic that isn't fully understood. As detection methods improved, the number of known fast radio bursts grew rapidly. What was once a rare anomaly became a catalog. Dozens, then hundreds, then thousands of events logged and analyzed. New telescopes, designed specifically to scan large portions of the sky, began catching these bursts in real time. Instead of looking back through old data, scientists could now watch as the universe produced them, and patterns began to emerge. Some repeating FRBs didn't just appear randomly, they followed cycles. One in particular showed a 16-day pattern. Bursts would occur for a few days, then stop completely, then return again after a period of silence. That kind of regularity is hard to ignore. It suggests motion, perhaps an object orbiting something else, or a system where visibility changes over time. Imagine a lighthouse but on a cosmic scale, not light sweeping across the ocean, but radio waves cutting through space. This led to new theories. Maybe the source wasn't a single object, but a system. A neutron star orbiting a companion, for example, interacting with its environment in a way that produces bursts only at certain points in its orbit. Or perhaps the bursts are being blocked or distorted by surrounding material, becoming visible only when conditions align. These ideas are grounded in physics. They don't require anything exotic beyond what we already know exists. But even so, they don't explain everything. Some signals show irregular timing, bursts that cluster and then disappear for long periods before returning. Others exhibit frequency patterns that shift in ways that are difficult to predict. It's not just that we don't have all the answers, it's that each answer seems to open up new questions. And then there's the precision. When scientists zoom in on these signals, breaking them down into finer detail, they find substructures within the bursts themselves, tiny variations in frequency and intensity that occur within microseconds. It's like taking a lightning strike and discovering that inside it are smaller, organized flashes, layered within the main event. That level of detail suggests a mechanism that is not purely chaotic. It suggests control, or at least a consistent process. Of course, control doesn't mean intelligence. Natural processes can produce incredibly complex patterns. But it does force researchers to consider models that go beyond simple explosions or random emissions. Something is driving these bursts, shaping them, repeating them. One of the more grounded explanations involves magnetars undergoing what are essentially starquakes. The crust of the neutron star shifts under immense stress, releasing energy in sudden bursts. These events could, in theory, repeat, especially if the star is in a particularly active phase. Observations have even linked some FRBs to known magnetars within our own galaxy, which strengthens the case. But there's a catch. Not all FRBs match that profile. Some are far more powerful than what we've observed from local magnetars. Others repeat in ways that don't align with known magnetar behavior. It's as if there are multiple categories of these signals, multiple origins, all being grouped under the same label because we don't yet have a better system. And that's where the uncertainty grows, because when a phenomenon refuses to fit into a single explanation, it usually means one of two things. Either we're missing something fundamental, or we're dealing with more than one underlying cause. In this case, both might be true. As telescopes became more precise, scientists were able to pinpoint the exact locations of some repeating FRBs. They traced them back to distant galaxies, some billions of light years away. And yet, despite all this data, despite years of observation and increasingly sophisticated models, one question remains stubbornly unanswered. Why do they repeat, not just physically, but fundamentally? What process produces bursts of this intensity in this pattern without destroying the source? What kind of system can generate that much energy over and over again and remain intact? There are theories, some elegant, some speculative, some bordering on the edge of what can currently be tested. As more data comes in, the picture is slowly sharpening, not into a clear answer, but into a more detailed mystery. We know more now than we did a decade ago. We know these signals are real. We know they come from distant galaxies. We know some of them repeat in structured ways. But the core question, what exactly is producing them, remains open. And maybe that's the most important part of this story, because it's a reminder that even now, with all our technology, all our models, all our accumulated knowledge, the universe still has the ability to surprise us. I post videos that break down how reality actually works, from your brain to your body to the world around you. So if that sounds interesting, subscribe, and I'll see you in the next one.